Good afternoon, Vora sir. Good afternoon, Vora sir.
Yes, good afternoon.
Good afternoon, sir. Welcome to STTP.
Have I been on time?
Sir, you are visible
Yes.
and you are audible as well.
Fine. So am I on time?
Yes, sir, you are right on right time. We can start. Let me ask our organizing team to start the formal welcome.
Sure.
Yeah. Organizing team, please.
Yes, sir. Yes, sir.
Yeah. Mhm.
Good afternoon to all, and I welcome you all for the TEQIP 3 sponsored online short-term training program on electric vehicles, which is jointly organized by Bharatiya Vidya Bhavan, Sardar Patel College of Engineering, and RAC Rewa in collaboration with III and SAE India Western Section. I would like to introduce our today's guest and speaker, that is Dr. K.C. Vora sir. Dr. K.C. Vora sir has done his bachelor's in mechanical engineering from DVM Vallabh Vidyanagar, master's in automobile engineering from VZTI Mumbai University, and his PhD from IIT Bombay. He has a vast industrial and academic experience of 35 years and has been associated with Walchandnagar Industries, Emitech Emission Controls, Mahindra and Mahindra, and ARAI. He has specialized in the field of education and technology development, soft skills, engine and emission controls, and electric mobility. He is an instrumental in starting ARAI Academy, which conducts BTech, MTech, and PhD courses in automotive engineering in collaboration with various universities. Presently, Dr. Vora sir is Senior Deputy Director and Head at ARAI Academy. Dr. Vora sir has 2 patents, 3 books, 2 reports, 32 international papers, and 65 national papers to his credit. He was the Secretary and Vice President of the Society of Automobile Engineers, SAE India, and conducts series of conferences, seminars, workshops, courses, and various students' activities. I request sir to please start with this session and enlighten everyone.
Can you please give me the sharing rights?
Yes, sir. You have the sharing rights.
Thank you. I am not able to share. Give me a minute. Are you able to see the presentation?
Sir, you just minimize this screen and then open the presentation. Then we will be able to see it.
Now?
So there's a white screen which we are able to see.
Okay. Fine. Give me a minute. I'll stop and start again. Okay. Present now your entire screen. Mhm. Yes. I hope you are able to see the screen now, the
Sir,
first
yes,
slide.
it is visible, sir. Right.
And now I'll make it full screen. Is it
Yes.
available now?
Yes, sir. It's perfectly visible.
Fine. And now I'm going to the second slide is going, right?
Yes, sir. It's going.
So with this background, and thank you very much for my introduction. And thank you for Professor Umale to invite me for this STTP. I'm going to speak on electric vehicles, standards, and research avenues. This is a faculty development program, right?
Both students as well as faculties.
Fine, fine. Okay. So I'm going to talk about what are the standards in the field of electric vehicle and what are the avenues for research for the students and for the faculty. So I'll start with the introduction. Electric vehicles are not very new. We have been doing research in the field of electric vehicles from 1830 onwards, when Robert Anderson and Thomas Parker developed electric vehicle. There are also taxis running in Paris and New York and later on in Detroit. However, when Henry Ford came with the first mass-produced Model T Ford, then the electric vehicle had a backlash, and it disappeared from the market by 1935. And then automobile as a passenger car with petrol and diesel engine became more popular. Now there are two reasons because of which electric vehicles are back. One, California Air Resource Board came out with a very strict norms, emission norms. One in 1970, which made catalytic converter and after treatment device compulsory. Another in 1990, which talked about zero emission mandate. And when it is zero emission mandate, we cannot use petrol engine and diesel engine. And that's how electric vehicles were advocated from 1990. The second reason is the oil crisis. The prices of the crude petroleum keeps on increasing and decreasing. So what was $25 per barrel can go as high as $300 per barrel, and then it will come down. And hence, people were not comfortable with oil import, and countries like India and including USA and Europe felt that we must get rid of our dependency on crude petroleum coming from OPEC countries. And hence the return of electric vehicle. So in 1991, Corvette and later Buddy models were very popular in Europe. Then came the Japanese, the Toyota, Honda, and Nissan, who were able to produce electric and hybrid vehicle. In India, Rewa Electric produced the first electric car in 2001. And that is the time when ARAI also started working on various standards. So we have been working on electric vehicle standard from last 20 years. Then came Tesla, and then electric vehicle became more popular. So there are various issues which we must discuss. One is related to economics, which I talked to you about the rising oil price. Second, the traffic in the cities are increasing. So more and more people are shifting from village to town and to cities, because of which the cities are populated not only with human beings but also with their vehicles. And this has reached to an extent where there are serious problems. There are congestion, there is emission, there is noise, and we need to work on it. Third, the environment point of view, the global warming is increasing, and because of which there is a climate change. And if we continue at this pace, then it will be very difficult for us to breathe fresh air in cities. And the next are policies, how governments of various countries are supporting the policies which advocate electric vehicle. So strict emission norms, CO2 emission mandate, and international policies and the treaties which we have signed related to environment, and National Mobility Electric Mission Plan, FAME2. These are some of the policies related to government which is supporting electric vehicle, and hence electric vehicles are becoming more and more popular. Moreover, by using electric vehicle, we will be able to reduce CO2 emission completely. Somebody will say that when we use a gasoline or diesel engine, there is a lot of emission produced. But when we use electric vehicle from the grid and the electricity generated through coal or gas, then CO2 is still produced at the place where electricity is generated. But if we start using renewable sources like wind energy and solar energy, then there is no CO2 emission, there is no NOx emission, there is no particulate emission, and we will be able to breathe really clean air. So with this mandate, how to reduce emission, how to reduce CO2 emission, in spite of such a huge population in Indian cities. You'll be surprised to know that India produced 25 million vehicles last year. And in spite of pandemic, the sale in October, November, December 2020 was higher than sale in October, November, December 2019. Two-wheeler itself, we have produced 21 million vehicles and so on. And hence, we need to work on this area. Even if we produce all electric vehicles, still there will be 250 million vehicles running on Indian road, which will be using conventional fuel. So we will not be able to reduce the emission drastically, but it will be a best step towards a best move towards that step. So India has really worked hard on electric mobility mission plan, and there are also, with the new government, with FAME, that is faster adoption and manufacturing of hybrid electric vehicle in India, through Niti Aayog, the think tank of India, we have been able to carve a niche area of electric vehicle, and we have started selling electric vehicle. There have been, through FAME 2, the focus has been on technology development, demand creation, pilot projects and charging infrastructure. We are slowly getting into the electric vehicle phase. And there are many startups and there are many shared mobility who have started using electric vehicle. Tata Motor and Mahindra has produced more than 10,000 vehicles and supplied to EESL, Energy Efficiency Service Limited. Niti Aayog, the think tank of India, has come out with a document of India Leaps Ahead, Transformation Mobility Solution for All. And they have predicted that India can save 64% of anticipated road-based mobility-related energy demand, and 37% of CO2 emission will be reduced by 2030. And it will also do a lot of saving, around 3.9 lakh crores of rupees in 2030, because we will be reducing our import of crude petroleum. FAME 1 had come, which was more related to the cost of the vehicle. FAME 2 has come, which is more related to the power of the motor in the batteries. And this is the final demand incentive for FAME 2. And this incentive can vary from 20,000 rupees to 50 lakh rupees. For example, recently I purchased an electric two-wheeler called Ether Energy, and I got a FAME subsidy of 29,000 rupees. So that is the advantage, and that is the incentive which government is giving. Worldwide, electric vehicles are produced, but countries like Norway have 55% penetration of electric vehicle in their country, even though the number of vehicles produced in that country is comparatively low. But still, if whatever vehicles are purchased, 55% are electric vehicle and 45% are IC engine vehicle, as on today. So there are countries like USA, China, and UK, and they have been very strongly advocating this electric vehicle in their country. India today, the penetration is only 0.1%. Next year or this year, it will be 1%. And maybe by 2030, our penetration would be around 10%, 10 to 20%. That is what is the prediction. So the prediction, Niti Aayog says that it will be 30%. And there are other sources like Goldman Sachs, which says by 2030, India's electric vehicle penetration would be around 8%. So in the year 17-18, we produced around 576 vehicles. In the year 18-19, we produced around 759 vehicles. In the year 19-20, we produced around 3,600 four-wheelers. And now we are slated to increase this 0.1% to 1%, and slowly by 2030, this will reach around 10%. There are different types of electric vehicles. There are some which are off-road, and there are some like two-wheeler, three-wheeler, four-wheeler, buses, out of which two-wheeler are more popular. So up till now, there were some two-wheeler which was with less than 250 watt of motor. There, no certification was required. But above 250 watt, then whatever is the wattage of the vehicle, we need to get that vehicle certified. Earlier, they were using lead acid battery, and now slowly, most of the manufacturers are shifting to lithium-ion batteries. As I told you, we started working from before 20 years. So in 1999, a committee was formed from ARI, VRD, ECMA, and CM to start working on type approval of electric vehicle or battery-operated vehicle. And AI standards were made, and the first standard was published in 2003. And then the mandatory requirement came in April 2005 that all electric vehicles sold in India above 250 watt needs to be tested and certified. ARI took the lead. ARI is also the secretariat to automotive industry standards, and various standards were made. Also, ARI is the only country in the world which has a standard for retrofitment. That means you can just remove the engine and put an e-kit there. This is under AI standard, that is automotive industry standard 123. Similarly, India is the only country which is advocating swapping of batteries. So if you don't have patience to wait and get your battery charged, you can just leave your battery, take another battery and move ahead, and later on swap it. So whether it is standard related to electric vehicles, standard related to hybrid electric vehicles, standard related to retrofitment, and standards related to charging stations, all of this have been released by ARAI. So these are some of the standards only for electric vehicle, like AIS 318, 319, 140, or 40, or AIS standards related to hybrid vehicle, which is AIS 102, or AI standard only related to lithium-ion battery, that is 048, or related to chargers like AIS 138 and 137. And then there are standards related to retrofitment, and that is AIS 123. And then there are so many other standards also. All these standards are released through government notification called General Statutory Rules or Statutory Rules and Order, SO or GSR. As I told you, below 250 watts, no certification is required, but still we need to give a certificate that it is below 250 and the maximum speed of the vehicle is less than 25 km/h. So that's how the beginning was done. But now we are talking about smart electric scooters, which can run as high as 80 km/h. Also, we had a GSR for e-rickshaw, where e-rickshaw can be converted into an electric vehicle, but with the condition that we must have various AI standards for this auto rickshaw type of vehicle, whether it is for public transport or good transport. So all those standards are mentioned in this. I'm sorry, the picture may not be very clear, but there are standards for three-wheeler. And then we have other standards like AIS 38, 39, 40, 41 for electric vehicle, and AIS 102 for electric hybrid vehicle, and AIS 123 part 1, 2, and 3 for retrofitment kits. So there are also standards AIS 138 for electric vehicle charging regulation, slow charging, fast charging, AC, DC. And there are standards for couplers and protocol standardization also. So India stresses more, and ARAI also stresses more on the safety of the vehicle. If I use an electric vehicle, what if it catches fire? So whether I am equipped with PPE, whether I am using the right safety precautions, and based on that, the safety check is ensured. So the phase one is safety check, whether it is EMI, EMC related safety, whether it is crash related safety, whether it is material related safety, we need to work in those areas, or electrical safety. So AIS 039 talks about measurement of electric energy consumption, and AIS 40 talks about measurement of the range, and AIS 41 talks about the measurement of power and all those things. So these are some of the standards, and electric vehicles are expected to meet these standards. So there are different types of electric vehicle, whether it's a pure electric vehicle or a plug-in hybrid vehicle or a hybrid electric vehicle, or it could be altogether a new vehicle which is running on fuel cells and so on. So a normal electric vehicle is a battery-equipped electric vehicle, where we have the battery in the front of the vehicle, and then we have a controller which converts DC into AC, and then runs the electric motor, and what comes out is through the gearbox to the wheel. So you can see the bottom of the car where we have a traction battery pack, we have an inverter, we have a battery management system, and we have a traction motor. So an electric vehicle is based on 4 important pillars. The first pillar is the electric machine, that is the motors. The second pillar is the battery, that is the energy storage system. And the third is power electronics and control. And finally, the fourth one is the one which takes care of the environment, and the energy management system or battery management system is the fourth pillar. So we are moving towards electric vehicle, we are moving towards hybridization, and we are talking about using electric module and IC engine module together. And you can see that there are various definitions of hybridization, whether you use a micro hybrid or a mild hybrid or a medium hybrid or a full power hybrid or plug-in hybrid. As far as a micro hybrid is concerned, it is just stop at the signal, and it has nothing to do with electric vehicle. The rest, it has to do with electric vehicle. Okay, so in an electric motor, we have the drive given through the battery DC voltage source, and through the controller and through the power modulator, we can run the motor. So this is how a typical motor looks like. It has a stator and it has a rotor. Okay, so there are different types of electric motors: permanent magnet motor, induction motor, and switch reluctance motor. And various companies use various types of motor. You can see most of them are using induction motor and permanent magnet motor, and very few are asking for synchronous reluctance motor. So we will have to take a decision between induction motor and permanent magnet motor. Okay. So the electric motor have their own characteristics. For example, at low speed, they are good at high torque, and high speed, they are good at high torque or high power. So when we select an electric motor, we need to know what vehicle it is, what are the specifications of the motor, and what is the motor system. That means whether there is an engine with fan, without fan, and then electric motor. And then there is a continuous power, torque, peak power, torque, maximum speed, cost, efficiency, volume, weight, RMS. So these are some of the criteria which is useful for the selection of a motor and controller. Okay, so when you are designing an electric vehicle or when you are selecting the electric vehicle, you may have various challenges and you may have various design options. So challenges could be in terms of cost, challenges could be in terms of sustainability, challenges could be in terms of efficiency. So all this needs to be solved. And similarly, in case of design, we know whether we are going to use induction motor or SRM or PM. We will have to decide the characteristics of the motor. So whether it is cost, whether it is performance, or whether it is durability versus life, we need to see the interaction of this, and then based on that decide the topology. Okay, I go ahead with the electric motor design. So electric motor design is slightly a difficult job, and you will have to have 2-3 iterations before you finalize the designs. Okay. So these are software related to electric motor design supplied by Altair. Okay, fine. In a motor design workflow, you start with an analytical design, then do a finite element analysis, then do thermal and structural integrity, and then finally do system analysis and also EMI, EMC in this motor design workflow. And there are various technology roadmap given for petrol engine and diesel engine. So there could be various configuration of motor, whether it is central drive or it is wheel hub drive derivatives. We need to work in those areas. Power electronics is another area, one of the pillar of this electric vehicles, where we are talking about some systems, we're talking about some power and energy, and we're talking about some electronics and devices. So basically, power electronics help us to convert DC into AC, and DC to DC converter also over there. And then, okay, fine. So whether it is DC to DC converter or rectifier, these are all part of power electronics. And for power electronics, again, we need to sit down with the fundamentals and then do the control design. And in power electronics, we also use embedded software in detail, based on which the optimization can be done. So there are various challenges related to the power electronics, subsystem performance, system performance, and the value chain, that we ensure that there is a short circuit protection and virtual EMC, power quality validation. All these are the values for this system. Okay. The third one is the energy management system. And in energy management system, you must know the state of charge, you must know the state of health, and you must know and so many other things. So we need to work in those areas also. Fine. Then the fourth one is, and the final one is the energy storage system. So I will take a break for 2 minutes, go to washroom and then come back. Please bear with me. We are almost 30-40% done, and we must be able to finish before 3. Umali sir, I'll just come back in 2 minutes. Is it okay? Hello?
Yes, sir, you can go ahead, sir.
Yeah, just 2 minutes. Okay, sir, I am back. Are you able to hear me? Hello?
Yes, sir, you're
Yes,
audible.
sir.
Yes,
Yes, sir.
Yes, sir.
Okay, fine. I was at energy management system or battery management system. Energy management system, which is popularly known as battery management system in electric vehicle, are one of the most important control mechanism or management mechanism in an electric vehicle. And there are different terms like SOC, state of charge, SOH, state of health, and cell balancing. And so there are various control parameters, and then they are controlled by various sensors and actuators. And battery management system is altogether a different art which we need to work on. We need to take care of the temperatures. We need to ensure that what is the charging, like we find out how much is our mobile charge, whether it is charged 80%, 90%. And we also ensure that if it goes below 10% or if it gets 100% discharge, then it takes time to charge back, right? So there are various terms like specific energy, specific power, energy density, power density, and also there are various nomenclatures like cell, modules, and pack, which makes together the entire battery system. We'll talk about it. But the temperature control is very, very important. So around 5 to 6 thermocouples are there around the batteries. And whenever the temperature goes above a particular stage 1, stage 2, stage 3, the cooling system starts. Cooling could be air convection through a fan, or a liquid immersion cooling, or a liquid cooling through channels. So like radiator, we can have a battery casing which can be made of aluminum alloy, and the coolant can pass through this, and so on. So a lot of work has been done in battery casing, and battery management system. So the credit for the lithium-ion battery must go to Professor John Goodenough. Professor John Goodenough is an American professor who invented this lithium-ion battery, and now he is working on glass battery, which is 3 times better than lithium-ion battery, and he's almost ready with it, right? There are others also like Baghdad battery and Alessandra Volta. These are all different people who have worked on battery from last so many years. But the practical lithium-ion battery was invented by Professor John Goodenough. I am sure in future, some of the professors like you in India or students like you in India can do some more research in this area. So batteries could be of different type. Lead acid battery is what we were using up till now. Even in electric vehicle, 3-wheeler electric vehicle, we use lead acid battery. Slowly, people are shifting to lithium-ion, but it's a costly affair. So whether it's a lithium-ion battery, nickel metal hybrid battery, or metal battery, there are different types of batteries, and there are different shapes and size of the batteries. For example, it can be cylindrical, it could be of a pouch type, or it may be of a prismatic cell type. So basically, a battery pack is made of series of modules, and the module is made of series of cells. So for example, a cell is a unit with a positive electrode, a negative electrode, and an electrolyte in between to transform the chemical energy into electrical energy, right? And a group of cells are called module, and a group of modules are called the entire battery pack. You can see some of the pictures of the battery pack here. So battery is one of the important criteria, and especially the lithium-ion battery. The lithium reserves in India is very less, except some part of Karnataka. So we import lithium or lithium-ion batteries. Up till now, we were importing it from Korea, China, but now our country, our Niti Aayog has signed MOU with Argentina and Bolivia. So most of our lithium reserve would come from Argentina and Bolivia. So in terms of battery, the challenge is various materials, design concepts, and also in battery, we need to check everything: electrical, thermal, structure, and chemistry. So ARIs have tied up with NCL for research on batteries, and also tied up with ISRO, where ISRO has been using some batteries in their space shuttle for a very long time, which is also of lithium-ion type, and that we're trying to find out the similarity and see how we can employ it for automotive application. So here has already made one a small electric battery based on ISRO design, which has been used for an electric two-wheeler application. So there may be different requirements for the battery depending on whether it is for a passenger car or a truck or a bus. So if it is bus, then you require higher power capability. And if it is a car or a two-wheeler, then we require higher energy storage. So there is a compromise between both of them. So there are different types of battery materials like lead acid, nickel cadmium, nickel metal hydride. And it is found that lithium ion has the highest specific power and also higher specific energy vis-a-vis. So I already talked to you about the availability of lithium in various countries, and Bolivia and Argentina are the two countries with whom we have tied up. Okay. There are various types of charging stations: slow charging, fast charging. And ARAI has worked extensively on the charging station and developed our own charging stations. So basically in a charging station, we need to ensure safety, scalability, saving, security, and simplicity. And then we also talked about FAME2 government initiative related to charging. And some chargers are available, which has certain number of charging points in certain range. But ARAI has developed its own in-house charging stations. So if anybody who is interested in the charging station can get the technology. So now I would come to the end of my presentation where I am going to ask you that what do we do in the field of electric vehicle? We have just kick-started our various avenues of electric vehicle research. But still there are a lot of black holes and we are not sure how are we going to work about. So what type of research we as a faculty or student must do? Can we make concepts, various concepts, and decide? Can we work on modeling, simulation, and optimization? We may be good at that. So we can have a training of various software and then work on modeling, simulation, and optimization, which automotive industry may find it cumbersome. Or can we make a prototype and become a startup? Can we make an EV retrofit? Can we work on battery swapping? Can we make a battery management system of our own? Can we do system integration? So these are some of the questions which come forward when we decide that we want to do research. And if any of your answer is yes, then we can go ahead. Okay. So worldwide, there is a process by which you can do the entire product development, validation, and final supply. So there is a process through which you can go, you can find out what are the requirements, what are the specifications, and do a functional design check, and then create subsystems, and then assemble them and test them and supply. So this is what is expected from product development B model. So there are various current research trends, like in electric vehicle architecture you can work on, or you can work on motors, you can work on energy management system, you can work on big data, artificial intelligence, high vehicle networking, energy storage solution, software hardwares, software architecture, and smart charging station. So these are the various areas of research, and based on your aptitude, you can pick up one and start. Okay. So there are series of electric motors available with us. So this somebody had asked for the flow chart. So this is how electric motors work in India. Okay. Then regarding battery management system or energy management system, lithium-ion batteries are much more preferable than the normal. And we also need to understand the supercapacitor and HESS, that is hybrid energy storage system. And the supercapacitor is used to energy storage undergoing frequent charge and discharge cycles. So if there is a charge and discharge cycle continuously, then we need to use an additional power source. Yes, we are also talking about smart charging and inductive charging, and based on which whether you have to charge at a particular spot or you are moving from one place to another and you have to recharge. what can you do to even slightly make it charge. So there are battery swapping stations, as I told you earlier. Okay, fine. So we need to find out some intelligent solution for charging, like a solar panel. So the most of the companies now have solar panel in their parking. So whenever an electric vehicle is parked, when the person enters the office, he has those 8 hours during which we can put it on slow charging, and the vehicle may get charged fully. There are also norms from framework from vehicle to grid and grid to vehicle. We need to use an electric vehicle to store energy or take the energy with us. Okay. So batteries need to be we need to be very careful. For example, the batteries can be charged when the vehicle is moving up to a railway line, or everyone may not have enough cash to pay the fees in this pandemic. So I'm sorry. I was saying that we need a framework for grid support for batteries. So there are various ways by which we can charge the batteries. We can charge the batteries, especially when the bus is running from the top, we can charge the battery. Or we can charge the battery when someone gets down for a refreshment, or for seeing a movie, or for shopping. So the position of battery charging stations would be different at different place. So now for the next 10-15 slides, I'm going to talk about the simulation technology and how, because this is the tool which makes students and faculty work faster and easier. So there are companies like Altair, like NSYS, Ricardo, GT, AVL, who all have this simulation technology to simulate electric vehicle. So to realize the goals of achieving the mass adoption and profitability, we see simulation technology as the cornerstone of any e-mobility strategy. So the simulation model which we are talking about e-mobility will be a system driven, where you first make concepts, you design, and then you validate, and then you buy. Okay. So these are some system where we first understand the customer's requirement, the voice of customer capture. Then we understand the function, then we understand the logical solution element, and then we use it with 100% validation. In electric vehicle development, if you want to start from scratch, you have various challenges. One is the range anxiety, whether this will go for 100 kilometers, 200 kilometers, or 250 kilometers. And also regarding the vehicle integration, that how do I package my entire vehicle and how do I interconnect all those parts? Safety and durability we talked about, and then the performance, and the final performance in terms of noise and vibration. So simulation can help us to design, simulation can help us to validate, simulation can help us to manufacture, and simulation can also help us to operate certain areas to a certain extent. So we have a multi-physics application for e-mobility. There are electric drive, there are electromagnetic AMI, EMC, and there are software control, and then there is a course on vehicle engineering and so on. So these are some of the software from Ricardo, which talks about 1D and 3D simulation. And these are also same requirement. And you can see that it has been divided into 4 parts, where we discuss motor and battery. Second, we can discuss BMS. Third, we can discuss the motor type selection. And finally, the demonstration pack. Okay. So whenever you want to model or simulate an electric vehicle, you need to work on various softwares like Structure, NVH, Fluid, and so on. So the simulation of electric vehicle is very, very important. So you cannot run it for 1 lakh or 2 lakh kilometer. People do that. But when it comes to motor, we have to be careful. Okay. Fluid dynamics is another area where we can analyze, and we can analyze with respect to stress, with respect to temperature. Noise and vibration are another area where we need to relook into. The noise of the e-kit is so low compared to the noise of an IC engine that more and more people are now shifting towards such area. So we need to work on sound radiation, we need to work on gear lab and so on. So from noise point of view also, electric vehicle noise is very less. Maybe we'll have to induce some noise somewhere so that the people walking on the footpath will know that a vehicle is coming from outside. So we need to develop an overall system specification and response required as an integral 1D and 3D simulation. So we will have to use various simulation to find out what is there in for us. So in short, this is my last slide. E-propulsion system, battery impact crashworthiness and occupant safety, battery system design procedure, comfort in pursuit quality, and so on. So as a student and as a professor, the best method is to work on various simulation techniques, then going into physical area. If that is okay, then I would like to conclude that electric vehicle, we need to take care right from raw material to some sub-component to component, and work extensively with the e-mobility area. So let's all work together for the penetration of electric vehicles in India. Thank you. Have I finished earlier?
Yes, sir, but we can take the questions, no problem. We can have discussion.
Sure.
So any questions? Question from audience? So there is one question in chat box you can refer to. Exposure to processes on recycling of automotive lithium ion batteries. Lab facility for recycling of these batteries in India.
Yeah. So we have started working on life cycle of a battery, and there are standards being developed. Not much work has been done in recycling of lithium-ion batteries. There is one center called GRC, Global Automotive Research Center in Orogadam near Chennai, where some work on recycling is done, but we have not started working on the recycling of lithium-ion battery, but very soon it would start. So there are many startups who are working on that. So if anyone is interested, I can connect.
Any other questions?
Thank you,
So
Vora, sir.
yes, please go ahead. So you were saying something?
No, sir. Just
Okay, so I have something to say. There are many young students who have started working in this, like whether they can have a business in charging, whether they can have a business in swapping, whether they can have a business in electric vehicle, or whether they can have buy some charging station and install it near their home. So lot of new things have come up in this pandemic. I think a lot of research, students got chance to do more research in this area, and that has been helpful. Using various softwares, learning various software, which the old softwares have become redundant and the new softwares have come in.
Thank you, sir.
Thank you.
So organizing committee, please do the concluding remarks. Organizing committee.
Thank you, Bhole sir. Thank you, Umalai sir.
Thank you, sir. हाँ, sir.
And thank you to the entire team.
Thank you, sir, for nice session on electrical vehicles. Thank you for your guidance on various aspects related to electric vehicles. So, participant, please note that we are having the next session at 3:30 p.m. by Dr. Sudhakar Umade. So, be here only. We will meet at 3:30 p.m. for the lecture by Dr. Sudhakar Umade. Thank you, sir.
Thank you. Bye bye, everyone. Thank you.
Thank you, sir.